All right, so this is 8.5, the coordinate plane. Could I have a volunteer read the learning target, Tanisha? Awesome, thanks. So what even is the coordinate plane? It is formed by the intersection of a horizontal number line, so one that goes side to side, and a vertical number line, one that goes up and down, so like this. That's what the coordinate plane is. The number lines intersect at the origin, so this middle point right there is called the origin. It is point 0, 0. And those two number lines separate the coordinate plane into 4 different sections. And those are called quadrants. Think about quad, means like 4, like a quadrilateral, or a quad, like, a vehicle that you're out driving. So quad is 4, so it separates it into 4 sections. You can sharpen your pencil. They are just simply named quadrant 1, quadrant 2, quadrant 3, and quadrant 4. However, it is very common that people label these using Roman numerals rather than the numbers that we write. So this, where it says quadrant I, that means quadrant 1. We just use an I rather than a 1. Over here is quadrant 2, because 2 I's is 2. I'm going to write Q2 just so you know that that's what it means. This one I have 3 I's, so that means Q3. And then in Roman numerals, the V represents 5. And if the smaller number is before the bigger number, that means you're subtracting them. So when it has IV, that means take V5 and take away 1, and you get 4. So this is quadrant 4. But just so you're familiar with the fact that we do label them generally with Roman numerals. So I is 1, 2 I's is 2, 3 I's is 3, IV is 4. One easy way to remember the order of the quadrants, because a lot of people think this is quadrant 2 because they're going in a clockwise motion. I had a student once tell me, if you draw a C on the coordinate plane, you're traveling through the quadrants in order. You start in 1, you go to 2, you go to 3, you go to 4. So if you're ever not sure which one is 2, think about drawing the letter C, and it goes to the left. That means to the left is 2, down is 3, and then into your last one over here is 4. We also need to remember that the names of these two number lines are called the x-axis and the y-axis. I always think x goes across and y goes to the sky. X is across, y goes to the sky, and they're labeled on here for you as well, x and y. An ordered pair is used to locate a point in the coordinate plane. So again, this is something you've seen before. An ordered pair has 2 numbers that are in parentheses separated by a comma. The first number always represents the x coordinate because x comes before y in the alphabet. And then the second number always represents the y coordinate because y comes after x. So in order to move to this point, 4, -2, I start at my origin. I start in the center. I move in my x direction, so that's either going to be left or right. Because I have +4, I'm going to move to the right 4. And then my y value, that's going to be up or down. Because it's -2, I'm going to go down 2. So this is where the point 4, -2 would be. So the new thing that we're learning today is that not only can you graph in what's called quadrant 1 with all positive values, you can also graph with negative values. So going to the left or going down to get into the world of negatives. We're going to go ahead and try out this example that says which ordered pair corresponds to point T. So point T is over here. I want you to discuss really quick with your team which one of these ordered pairs, A, B, C, or D, do you think is correctly naming where point T is at? Ready, go. Okay, does anybody think they know what one it is and can tell us why? Which one and why? Dash?
It's C because it goes over 3 to the right and then it goes down 3.
Exactly, and they go in XY order because down, that's a Y value, so the negative value should be that Y value or that second one, because sometimes we might think, oh, it's B, But remember, the first value is x, and that was positive. The second value is y, and that was negative. Questions about why that's the answer for this one? Awesome. We're going to move into the next section, which is now reflecting. Nope, sorry, we're not going to reflect yet. I lied. We're going to do a few more examples. We're going to plot some more points to get a little more practice, and then describe the location of each point. By describe the location, what that means is tell us which quadrant is it in. So A, that's -2, 3. So I start at 0. What does -2, if that's my first value, which direction am I supposed to be moving, and by how much, if my first number is -2? Ratisha? Yep, because x is left or right, negative means left 2. And then my next number is a +3. So now which direction should I go, and by how much? Shelby? Because y is up or down, positive means up. So it would land here, 2 to the left and 3 up. So I've done the first part, I've plotted it. Now I need to describe its location. Who can tell us which quadrant this is in? Natalie? And I'm going to write it with the Roman numerals. Quadrant 2. It's like 2 I's. Quadrant 2. If you're like, what the heck? You can write Q2 so you remember that's what it means. And then we have a second one we're supposed to graph. This one is 0, -3.5. So again, we always start at the origin, 0, 0. If my first number is 0, what does that mean I should do? Like, which way should I move and how much? Aubrey? Awesome. And if my second number is -3.5, which way should I move and how much? Neil? So down 1, 2, 3, and then a half would be just in between. Right there. Okay. Discuss with your group. How would you describe the location of this point? Like, what quadrant would you describe it to be in? Ready to go? All right, what do you guys think? Who has an idea? What do you think? Ratisha? Okay, so Ratisha said quadrant 3 and 4. I heard a lot of the people say something similar because it's kind of in between. Sorry. So when it's between quadrants like this, it's not really in either one. There's actually a slightly different way we can describe its location because it kind of is like right between them, right in both. Does anybody have a different way you can maybe describe it? Ethan?
We said that it's on the y-axis.
On the y-axis. Because it is like right between quadrant 3 or quadrant 4. So how do we decide what to say? Well, we just say it's not in either. It is on an axis. In this case, it's on the y-axis. Questions about that one? Okay. So the last thing we're going to do, we've now talked about how to graph the location of points. We're now going to go into reflecting points. So when we reflect a point in the coordinate plane, that means to reflect either over the y-axis, so treat the y-axis like a mirror and hop to the other side, or reflect over the x-axis. Again, treat the x-axis like a mirror and hop over the other side. Sometimes we reflect over both axes, so that means you're going to have to move twice. First over the y, then over the x. There actually is a rule for how to reflect a point, meaning you shouldn't even need to graph it to know what the reflected point will be, what its location would be. Here's the rule. If you are reflecting a point in the x-axis, so across this horizontal axis, the x-coordinate remains the same, but the y-coordinate becomes its opposite because we're jumping either from the positive into the negative or from the negative into the positive. If we're reflecting over the y-axis, so over this vertical axis, we do the opposite thing. The y value would remain the same. It's going to stay at the same height wherever it's at, but because it's jumping over, it's going to become an opposite x value. So the x value will either go from positive to negative or from negative to positive. If we are reflecting over both axes, both values become their opposites because we are making both movements. We are going to use a coordinate plane to show the reflection, but we also just want to know that this is a rule that we can always go back to. So this says reflect -2, 4 in the x-axis. So like I said, I'm going to do this by actually just graphing the point and then looking at, like, logically where would the reflected point land. So -2, 4, that's left 2 and up 4. I haven't reflected it. All I did was just graph it so I know where it's at. If I'm reflecting over the x-axis, this is my x-axis, so it means I'm jumping across this. I'm treating this like my mirror, and I want to go to the other side. Does anybody think they know where it would end up landing when we do that, if we go from up here over down here? Mia? I'm looking for an ordered pair, like the two numbers that describe its full location. Yeah, because it's going to stay on this -2. It's not going to move in the x direction at all, but it's going to go up from +4 down to -4. That would be where the reflected point for part A would be. Its coordinates are -2, -4. Look how x stayed the same, but y became its opposite, because when we reflect over the x-axis, x stays the same. It's the y that becomes its opposite. We're now going to graph this one and reflect it, but over the y-axis. So -3, -1, here's how I would get there. Left 3, down 1. Again, I haven't answered the question. All I did was just see where that's at. And it said reflect over the y-axis, so this time y is like my mirror, and I'm jumping over this line. So from here over to here. Who can tell me where you think the new point would land, what its coordinates would be if I jump over to the other side? Where would it land? Logan? Right there? So that one is a little closer to my mirror than this one. So it's not a perfect mirror image. I need it to be a perfect mirror image. Like, these ones are equal distances away. Kaden? -3, 1 would be here. That would be jumping over my x-axis. I want to jump over the y-axis. You meant what? That's where I already am at. I'm at -3, -1 right now already. Tanisha? 3, -1. I want to be over the line, the same distance away, 3 away, but on the other side. So 3, -1. Notice that this time when I reflected over the y-axis, y remained the same. That -1 remained the same. It was the x that became its opposite. So whichever axis you are reflecting over, that coordinate stays the same. It's the other one that turns into its opposite. So now the last one I'm going to do is 2, 1. So that's over 2, up 1. And this time it says to reflect over both the x-axis and the y-axis. It says x followed by y. So that means I have to do 2 reflections. First, I'm going to reflect over x, so over this. Who can tell me where that would land if I'm reflecting over this? Dash?
-2, 1.
That would be here. That would be reflecting over the y. I want to reflect over the x. Natalie?
2, -1.
And again, notice when we reflected over x, x stayed the same. It stayed 2. It was the y that became its opposite. Instead of +1, it became -1. Now I'm taking my new point and reflecting that one over the y-axis. So I'm right here at 2, -1. If I jump this over my y-axis, where would it land? Neil? And again, notice that when we reflect over y stayed the same. The second number stayed -1. It was the x that went from +2 to -2. So its final location was -2, -1. And that makes total sense, because if I reflected over both axes, both numbers should be becoming the opposite. 2 became -2, 1 became -1. Questions about that one?